it a fire triangle or a fire tetrahedron? It's a hot topic because while some exams for NEBOSH and IOSH focuses on fire triangle, whereas CSP and CRSP certifications require understanding of the fire tetrahedron. Confusing, isn't it? But fear not. We are here to clear the smoke and shine a light on the key differences between these two models. Hello health and safety professionals. Welcome to Vocational Safety. I am Roshan Rajesh and I bring over 15 years of work experience in the field of occupational health and safety. I am certified safety professional, a Canadian registered safety professional, a chartered member of IOSH and a qualified trainer and assessor. Here on this channel, we simplify complex safety topics into practical and easy to follow steps, all designed to help you build a safer and healthier workplace. So whether you are a seasoned professional or just getting started, our goal is simple: to give you the tools, tips and real world knowledge you need to protect people and prevent harm. And if you are preparing for NEBOSH, IOSH, CSP or CSP exams, you are in the right place. These videos are built to support your success. In today's video, we are diving into one of the most fundamental, yet often misunderstood topics in fire safety: fire triangle versus fire tetrahedron. Whether you are a frontline safety officer or a site supervisor or preparing for certifications like NEBOSH, IOSH, CSP or CRSP, this video is going to give you clarity on how fire starts, how it spreads, and more importantly, how to stop them. So here is what we will cover today. So we'll start with the fire triangle. We'll break down the three essential elements that allow fire to exist using simple practical examples. After that, we'll talk about the missing element. So what's the fourth element that turns a basic triangle into a complete fire behavior model, and why modern fire science depends on it. After that, we'll go towards the science behind fire extinguishment, when to use each model and why one is more powerful in real world scenarios. And then we'll look at some of the frequently asked questions in quick fire section, where I'll answer some of the important questions professionals and students ask. Alright, let's begin with the foundation of fire science, the fire triangle. Now, if you have ever wondered how exactly does fire starts, so this is where it all begins. Every fire, yes, every single one requires three key elements to exist: fuel, oxygen and heat. So think of this as a triangle. Each side supports other, right? So triangle is fuel, oxygen and heat, right? Each side supports the others. Remove one side and the triangle collapses. So does the fire. So let's break it down. Fuel. What will burn? So fuel is anything that can combust, right? This can be solid like paper, wood, even plastic, right? Then heat. What ignites the fire? Heat is the ignition source. So it raises the fuel to its flash point, the minimum temperature where vapors can ignite. So examples of heat sources could be an electrical fire, right? Or maybe it could be a friction, and so on, right? A tip here is like a small spark may seem harmless, but if fuel and oxygens are present, that's a complete triangle. Now let's look at oxygen. What keeps it going, right? Oxygen supports combustion. In most cases, we are talking about 21% of oxygen in normal air, but in industrial settings, even oxidizing agents like nitrates can fuel the fire faster. So oxygen is there, 21% we consider, right? So in confined spaces, controlling oxygen concentration is a life-saving technique. We'll touch on that in later videos, but now let's focus on our fire triangle, right? So now you know fire isn't just a random act, it's a predictable and preventable, right? It requires three different elements. So even if one of these three elements is missing, fire cannot start or continue. So if you want to prevent a fire, remove one element of the fire triangle. If there is no heat, no ignition. No fuel, nothing to burn. If there's no oxygen, fire will suffocate. Same like us, we need oxygen to survive, so does fire. So now what if I told you that there is a fourth element that makes fire even harder to control? And that's where the fire tetrahedron comes in. And it's not just a theory, it's why some fire reignite and even after triangle is broken, it continues. So fire tetrahedron, the missing element. Now that we have nailed the basic with the fire triangle, let's go one step further, because in real world fire, especially in industrial incidents, there is often a fourth factor at play that the triangle doesn't explain. So why do some fire reignite even when heat or fuel, oxygen are under control? That's because of what we call the fire tetrahedron, the 4D version of fire. So this is where the fourth element of fire comes in picture, and it becomes like a pyramid now. So it's called chemical chain reaction, right? So this is the fourth element of the fire tetrahedron, right? So the fire triangle evolves into the fire tetrahedron when you add one more essential element, a self-sustaining chemical chain reaction. What is the chemical chain reaction? So when fire burns, molecules break apart and react in a chain sequence, like constantly, and it continuously releases more heat and keeping the fire alive. In essence, the fire begins to feed itself. This is especially critical in flammable vapors or dust explosion or metal fires, for example, magnesium or titanium. So these reactions don't just burn, they multiply. And unless the chain is interrupted, the fire keeps going. Now, why this tetrahedron matters? Some extinguishing agents like water, it's difficult to stop chain reaction. That's why we use foam, dry powder, or carbon dioxide for flammable liquids or electrical fires. So these agents not only remove oxygen or cool the fire, but also disrupt that chemical chain reaction. So in simple language, fire triangle starts the fire, fire tetrahedron explain how it keeps going. And if we talk about control measures must account for the chain reaction, not just the triangle. So now we have expanded our fire model from basic triangle to a powerful tetrahedron, giving us a complete picture of how fires ignite, sustain, and intensify. Now let's look at the science behind fire extinguishment. Disrupting the elements, fire extinguishers work by disrupting the element of the fire triangles or tetrahedron. Now let's see how they target each element. For example, heat removal or cooling. Water-based extinguisher, for example, work by reducing the temperature of the burning material, especially when it is class A fire, that is solid material, such as wood that is on fire. We have made another video on classification of fire, so you can watch it for more details. The link would be in the description box. Then there is oxygen removal. We also call it as smothering. Cutting off the oxygen supply is another way to extinguish fire. Fire blankets and specialized carbon dioxide extinguishers work on this principle. You can watch this clip for our training session to see how carbon dioxide extinguisher smothers fire by cutting off or displacing oxygen supply.
Okay, pull the pin, aim at base of the fire, and squeeze.
Then there is fuel removal or starvation. While not always practical removing fuel, but it can also extinguish fire, right? So this could involve turning off the gas valve or removing flammable material. So the big question is fire triangle or fire tetrahedron? The answer is both. The fire triangle offers a basic understanding, while the fire tetrahedron gives a more complete picture with the chemical chain reaction element. Why the tetrahedron is more accurate? Because including the chemical chain reaction, the fire tetrahedron provides more comprehensive picture of fire. It highlights that simply removing one element, fuel, oxygen, or heat, extinguishes a fire because it disrupts that self-sustaining cycle. So what are the benefits of understanding both models? Understanding the chemical chain reaction element helps predict fire behavior better, and knowing both models is crucial for various occupational health and safety exams. Next video will be delving deeper into the different classes of fire and the types of fire extinguisher best suited for each. Knowing which extinguisher to use can make all the difference in an emergency. So stay tuned and do not forget to subscribe to the channel. Now let's move to quick fire section. So this is where we crush the confusion with clear answers to the trickiest fire science questions. So following are the 4 stages of fire development, right? Let's look at it. So for that we will have to draw a graph, right? So here we have time and here we have heat, release rate, right? And in this graph, this is the curve that we are talking about, right? And in this curve we have different stages, right? Starting with the incipient one. So this is one stage, second, third, and the last one. So starting with first one, that is incipient stage, right? Then the fire goes into growth phase, right? When it starts burning out, then it reaches to fully developed stage, and at the end it comes back to decay stage, right? So fires are predictable, right? They develop in stages as we discussed. Let's look at each stage in detail now. We know when to act and how to control it if we know which stage it is in, right? So starting with incipient stage where it gets ignited. So this is the birth of fire where heat, fuel and oxygen have just combined, but the flame is small and often still smokeless. So that is incipient stage. In this stage, early detection systems like smoke detectors and heat sensors are most effective. This is your best chance to extinguish it with the fire extinguisher or by isolating the fuel sources. After this, fire goes to second stage, that is growth stage. The fire is now building a strength. It's feeding on more material and temperature and it's rising fast. Hot gases collect at the ceiling level and preheating items below it. This can trigger a flashover where the room suddenly ignites, and this is when the fire compartmentation and suppression systems like sprinklers are essential. After growth stage, fire goes to fully developed stage. Now this is the most dangerous stage, right? Because everything that can burn is burning. So oxygen is being rapidly consumed. Temperatures can exceed 1000 degrees Celsius in enclosed spaces. Now fire is uncontrollable without full emergency intervention. So that is fully developed and most dangerous stage. After that, there is a next stage or last stage is decay stage, right? Fuel is nearly exhausted in this stage because it has burned everything in the fully developed stage, or even oxygen is depleted, right? So the flame start dying down, but it's not over. Toxic gases like carbon monoxide are their peak here, and it can start reignition, which is still possible. So after understanding the 4 stages of fire development, now let's understand what is secondary explosions or secondary fires. So chain reaction in dust explosions are a major factor contributing to this secondary fires. Primary dust explosions can dislodge accumulated dust, creating a larger, more combustible dust cloud that then can get ignited, which could lead to a secondary explosion and potentially a fire, right? So these secondary explosions can be far more destructive than the initial blast due to the increased amount and concentration of airborne dust. So today we covered the foundation of fire science, starting with fire triangle, then understanding how the fire tetrahedron gives us deeper insight into how fire sustain and how it grows. Understanding this model isn't just for exams. It's critical for designing fire prevention systems, conducting proper risk assessment, and protecting lives at work. If you found this video helpful, I have curated custom playlists for you that goes deeper into fire safety and some other topics such as risk assessment. Make sure to subscribe and leave a comment to share your biggest takeaway and like the videos if it had helped you. So thanks for watching. I'll see you in the next video. Until then, stay safe.